All right, this is section 1.2, day 1. Today we're focusing on linear measure, so the measure or the length of a line. And tomorrow we're going to be talking about the distance formula. So our big vocab word for today is collinear. We already know that word. Collinear means on the same line. In this example, points A, B, and C are collinear. So A, B, and C are on the same line. We have a diagram already for us, but we might not always have that. Later on in this lesson, we may have to draw our own picture. We want to find AB when we have two capital letters right next to each other, like we do there with A and B. That is math shorthand for the distance between point A and point B. Mathematicians love shortcuts, shorter ways to write things. That's why we have so many symbols in math. So whenever you see two capital letters squished together in this class, that means the distance between those 2 points. So in order to find the distance between those 2 points, I'm going to use the fact that I know the distance between A and C. I know the distance between B and C. And I want to find that green section between A and B. If AC is the whole segment and BC is a chunk of the segment, the missing chunk, AB, can be found by subtracting BC from AC. So in other words, AC, the distance between A and C, is the same thing as the distance between A and B plus the distance between B and C. I know that AC is 13.2 meters. I want to find AB. I know BC is 5.8 meters. So to solve for AB, think of it as a variable. I would subtract 5.8 from each side. So AB, the distance between point A and point B, is going to be 7.4 meters. All right, similarly, if PR is 28 units with this diagram, I want to solve for a bunch of different things. We're going to do a really similar process. We've just got some variables in there this time. So I know PR, this entire segment is 28 units. PR is made up of the smaller segments, PQ and QR. PR is 28 units. I know PQ is given by the expression 2x plus 1. QR is just an x. So the entire length of PR will be 3x plus 1. The first thing I want to find in A, we're solving for x. So I'll just solve this equation. X is going to be 9. Next thing I wanted to find was PQ. I know PQ is given by the expression 2x plus 1. We already found out x. That was 9. So PQ should be 19 units. QR is just X, and X we already knew was 9. So QR will be 9 as well. We can double check that. We know that PR, the entire segment, is 28 units. It's made up of PQ and QR. PQ is 19, QR is 9. 19 plus 9 is 28. All right, a new vocab word for today is going to be congruent segments. Congruent segments are line segments that have the same length. So if I were to measure RH and SQ, they would have the exact same length. When we measure something and we find that it has the same length, we mark it with a congruent symbol, which is just a tick mark on each line. If we have multiple congruent things in a picture, we might use 2, 3, even 4 symbols to show that those things are congruent. The sign for congruent, if we wanted to write some sort of mathematical sentence, is an equal sign with a squiggle over the top. So if I wanted to write a statement relating these two lines, I could say that segment RH is congruent to segment SQ. Make sure you have those symbols on the top to show that they are segments. You cannot have the statement without those. Instead, we would show that with an equal sign. So when we use a congruent sign, we're comparing two defined terms. So two segments, 2 points, 2 lines, 2 planes, whatever. When we have an equal sign, we're talking about real world numbers. So either you have the line segments and you have the squiggle to show congruence, or you do not have the line segments and you use an equal sign. So here RH is congruent to SQ. All right, this is our last example in this video. We're getting a little more complicated. We'll throw some variables in there. Points A, B, C, D, and E are collinear on the same line. AB is equal to BD, which is equal to DC. I could also put some segment symbols over there, but then I would have to add a congruent symbol. So segment AB is congruent to segment BD, which is congruent to segment DC. That means they all have the same measure. Since they're all the same, but we don't know what that number is, let's give it a variable. Let's say AB, BD, and DC are all going to be X units. AE, the distance between A and E, is 345 units. EC, again, those two capital letters mean the distance between point E and point C is 186 units. I want to find BD, so I want to find this guy, and AD. So that would be that distance. This is actually just like the first problem we did, only we've got some variables in there this time. So our entire segment AE is made up of a whole bunch of little segments put together. So let's write that as an equation. AE, again, that's the distance between point A and point E, is going to be AB plus BD plus DC plus CE. Well, we know that AB, BD, and DC are all the same. Those are all X. We know CE was 186. They gave that to us. And we know AE was 345. I want to find AB and AD. In order to do that, I'm going to have to figure out what this x is. Let's solve this equation. I'll subtract 186 on each side. So 159 will equal 3x. And then I'm going to divide each side by 3. So x should be 53. So we wanted to find BD and AD. Oh, I may have labeled our diagram wrong at the beginning. I'm not going to go back and fix that, but the segments that we're trying to find are BD and AD. Good job if you caught that. BD is x, and we already figured out x was 53 units. AD is going to be AB and BD put together, 2x, or 106 units. That's all for this video. We'll do some more practice with this same material in class.